Before you analyze data, you have to make a decision, not about formulas or software, but about what kind of evidence you are willing to accept. That decision is called one tail versus two tail testing. And here's what makes this decision important: it quietly determines where you look for evidence, how you interpret surprise, and whether result feels convincing or not. Welcome back to Shital's Data Desk. I'm Shital, and in this video, we are going to break down one-tailed and two-tailed test visually, without formulas, without jargon, and without shortcuts. We will start by understanding what tail actually mean in probability distribution. Then we will see how one-tailed and two-tailed test ask different questions, even when data is same. We will explore how this choice changed p-value, while choosing after seeing data is serious mistake, and how real world contexts like medicine, business, and experiments influence correct choice. Finally, we will bring everything together with simple decision framework you can use before running any test. Before we talk about one-tailed test or two-tailed test, we need to slow down and ask simpler question. What is a tail really? Because in statistics, tail is not a direction. It is not left or right, and it is definitely not about positive or negative numbers. Tail is about rarity. Most outcomes cluster near center. That center represents what we expect to happen when randomness alone is in control. As we move away from center, outcomes become less common. And the further we go, more surprising they become. Those extreme, rare regions at the edge of distribution are what we call tails. Now, here's the key idea: tail represents how surprised we are willing to be before we stop blaming randomness. That's it. Not truth, not certainty, just surprise. If your result falls near the center, it looks normal. If it falls deep into tail, it looks unusual. And deeper into the tail it goes, harder it is to explain using randomness alone. Now here's where decision comes in. When we design hypothesis test, we have to decide in advance. Do we care about surprises in one specific direction, or do we care about surprises in either direction? That single decision determines how many tails we pay attention to. And that's exactly where one-tailed and two-tailed tests diverge. Now that we understand what tail represents, rarity under randomness, we can talk about first major choice in hypothesis testing. Do we care about one direction or both? Let's start with one-tailed test. In one-tailed test, you are making decision before seeing data. You are saying, I will only be surprised if result goes in this direction. Not any difference, not change in general, a specific direction. Think about real example. You taste new drug. Your claim is not just that it's different. Your claim is that it reduces symptoms. If symptoms increase, that's not evidence for your claim. So you focus all your attention on one tail of the distribution. This has an important consequence. All the probability and skepticism is concentrated in one place. That means same observed result will look more extreme than it would in two-tailed test. This is why one-tailed test can produce smaller p-values for same result. But this power comes with a rule. One-tailed test only makes sense if you are truly willing to ignore opposite direction. Not because it looks inconvenient, but because conceptually it does not support your claim. If you wouldn't accept large effect in the opposite direction as meaningful, then one-tailed test may be justified. So let's log this idea in. One-tailed test asks, is the result extreme in one pre-specified direction? They are focused, they are powerful, and they demand discipline. But what if you don't want to ignore half of the distribution? What if you care about surprises in either direction, positive or negative? That brings us to tail test. This is the most common choice in statistics, and for good reason. In two-tailed test, you are not committing to a single direction. You are saying, I care about any result that looks unlikely under randomness, higher or lower, positive or negative. increase or decrease. If it is far from what randomness predicts, it matters. Think about typical research question. You compare two teaching methods. You don't know which one is better. You only want to know whether they are different at all. In that case, ignoring one side of the distribution would make no sense. So you split your skepticism. In two-tailed test, same total probability is divided across both tails. That means each tail gets less room. So for a result to look extreme, it has to be more extreme than in one-tailed test. This is why two-tailed tests often produce larger p-values for the same data. But this is not weakness. It's a statement of caution. Two-tailed test says, I am open to being surprised in either direction, but I need stronger evidence. That's why two-tailed tests are default in most fields. They protect against bias, they protect against wishful thinking, and they make fewer assumptions. So let's summarize. Two-tailed test ask, is the result extreme in either direction? They are balanced, they are conservative, and they are honest about uncertainty. Now we have seen both choices, one-tailed and two-tailed. But here's the real question. How do you choose between one-tailed and two-tailed test? Not by looking at data or p-value, but by answering one question before analysis begins. Here's the rule. Ask whether results in both directions are meaningful. That's it. If results in both directions would count as evidence, you must choose two-tailed test. If results in only one direction would count as evidence, one-tailed test may be appropriate. This decision is not statistical, it is conceptual. It depends on what your question allows, what outcomes you consider relevant, what you define as evidence. Once that decision is made, test follows automatically. And here's the most important part of the rule. Tail choice must be made before seeing data, not after or conditionally or even when results are close. Because p-values are calculated under the assumption that this decision was fixed in advance. So let's summarize the rule clearly. Two-tailed test when both directions are meaningful, and one-tailed test when only one direction is meaningful. No shortcuts, no flexibility after the fact, just a clear rule applied before analysis begins. Let's look at most common and most dangerous errors people make with tails and p-values. Most errors with one-tailed and two-tailed test don't come from confusion, they come from temptation. Imagine this situation. You run two-tailed test. Your p-value comes out as 0.08, not significant. Then someone says, what if we used one-tailed test instead? Suddenly, p-value drops below 0.05, and that's where danger begins. This practice has a name, p-hacking by tail switching. You didn't change data, you didn't run new experiment. You changed rules after seeing outcome. That weakens logic of statistical testing. Here's why this is a problem. P-value assumes hypothesis was fixed in advance. Test was chosen in advance. Direction was specified in advance. Once you peek at the data and then decide, p-value no longer mean what you think it means. It's no longer measure of rarity. It is just a number. Another common mistake is using one-tailed test when opposite outcome would actually matter. For example, claiming a drug only helps when harm is possible. Claiming performance can only increase when failure is realistic. This artificially boosts significance by pretending one side of reality doesn't exist. Statistics doesn't reward optimism, it rewards honesty. And here's the subtle mistake many beginners make, thinking that one tailed tests are more powerful, so they are always better. Power comes from justified assumptions, not from cutting probability in half. If assumption is wrong, your conclusion is weaker, not stronger. So remember this rule. One tailed test is not a shortcut, it is commitment. Commitment to a direction before data speaks. One tailed versus two tailed tests are not about math, they are about consequences. Different fields make different choices because cost of being wrong is different. In medical research, both directions matter. Treatment might help, it might do nothing, or it might cause harm. If harm is possible, we cannot ignore it. That's why medical studies almost always use two-tailed test. They ask, could effect be meaningfully different in either direction? In business, question is often more focused. If new feature is designed only to increase conversions, we may care about just one direction. We are not asking, could this be worse? We are asking, did it improve things enough to matter? In those cases, one tail test can be appropriate, but only if decision is made in advance. In early research, we often don't know what to expect. Surprises matter. Unexpected directions matter. So researchers usually choose two-tailed tests to stay open to all possibilities. So the choice is never about preference. It is about what outcomes matter, what mistakes are acceptable, and what risk you are willing to take. Once you see this, one-tailed and two-tailed tests stop feeling technical and start feeling ethical. So, if choice depends on consequences, how do you make that decision in practice? So, how do you actually choose between one tailed and two tailed tails? Not with intuition, not after seeing data, but by answering three questions in advance. First, do you care about both directions? Ask yourself. If answer is yes, you need two tailed test. If no, one tailed test may be acceptable. Question 2. Was the direction decided before data? This is critical. If you decide direction after seeing results, you are no longer testing, you are rationalizing. One tail tests are only valid when direction is clearly stated, logically justified, locked in before analysis. No exceptions. Question 3. What is the cost of being wrong? If being wrong in either direction is costly, use two-tailed test. If only one direction truly matters and other is irrelevant, one-tailed test may be justified. Rule of thumb is when in doubt, choose two tailed. It is more conservative, more defensible, and harder to misuse. So now you know how to choose. Let's step back and lock in one idea you should remember every time you see p value. One tailed and two tailed tests are not about statistic tricks, they are about honesty. Honesty about what to expect, what you are willing to accept, and what you are prepared to ignore. P-value doesn't make decisions for you. It reflects decision you already made before data spoke. So always remember, tail is chosen first, data comes second, interpretation comes last. When you respect that order, statistics becomes clear, stronger and far more trustworthy. If you found this video helpful, don't forget to like, share and subscribe to Shital's Data Desk. Thanks for watching and I'll see you in the next video.